Would anybody like to answer this? Or part of it? Is it gravitational force, electromagnetic force, nuclear force, weak force? When two surfaces are in contact, which type of force did we discuss?
Sir, electromagnetic force.
Electromagnetic force. Will it be electromagnetic in all cases or some cases?
Sir, it will be in the first case.
U on the pen. Yes. U on the pen is certainly electromagnetic.
Electromagnetic force.
Right? Fingers pressing. That's electromagnetic.
Sir, and by the pen
on the notebook
is also electromagnetic.
Yes. You are pressing
yes,
the notebook with the tip.
So the
that's electromagnetic.
Tip and paper is rubbed.
By you on the notebook?
Sir, we are not directly...
Okay, often... Yes.
We are not directly applying on the notebook, no sir, force.
Yes.
We are applying it through pen, so it will be tension.
0? By you on the notebook is 0?
I hope so.
Okay, let's ignore that palm. Often we would keep palm when we write. So palm actually presses the notebook a bit, but if we just ignore that aspect and concentrate on the pen thing, then the answer is 0. You don't apply any force on the notebook. And the other two forces are electromagnetic. Very much technically speaking, you do apply gravitational force on the notebook. Any two masses would attract each other via gravitational force, but that's simply meaningless. It will be so small. Any questions? Let me know. Well, you know what options I'm going to give. Let me just delete the 4 types that we have discussed. Which one is that? Gravitational, electromagnetic, nuclear, or weak?
Sir, electromagnetic force.
Sir, electromagnetic.
Because of the frictions between the two palms.
It doesn't have to be friction. You just hold. You just hold hand, there's no friction. There's no friction involved. Contact force. Normal reaction, let's say. Reaction, let us say. In assignment, I noticed somebody saying that there would be friction between the table and the surface. Between the table and the surface. When the table is just kept on the surface, there is no friction between the table and the surface. When you move the table, when the table moves, then there is rubbing. Then there can be friction between the table and the surface. Or if you just push the table and table doesn't move, then there is static friction. But if you're not pushing the table at all, table is just resting on the surface, there is no friction. So one person holds other person's hand like that, no friction. But yes, when he rubs like that, then there is friction. Electromagnetic force is the correct answer. What do you think?
Sir, a nuclear
Sir, option A.
electromagnetic gravitational. Option A.
Option A, sir.
Option A. Are you saying option A? Nuclear force between electrons?
Yes, sir. Option A.
What is nuclear force?
Sir, option B would be the answer. Force is the
Option B.
force between two nucleons.
Two nucleons. So between two electrons, which are not nucleons, what should be the nuclear force? Nuclear force is between two nucleons. Electrons are not nucleons. So what should be the nuclear force
It
between
will be
two
the
electrons?
least.
Zero. It will be zero. It will be the least.
Sir,
Zero
answer
or
B.
least.
Sir, option D.
Answer B.
B, sir.
D for delta or B for beta?
B for beta.
Delta. Beta doesn't make sense because nuclear force is just not there between two electrons, just not there. Gravitational force is meaningless, but it is 0.000, several zeros, but after several zeros, one will come in capital G, gravitational force between two electrons. It will be terribly weak, but it will be there. But nuclear force will just not be there. So N cannot be more than G. So I would go for delta. Delta is the correct answer. Any questions? Let me know. So what's the choice?
So answer C.
Answer C.
Sir, C1.
The problem is the word only.
Sir, is it option D?
Okay, why is it D? Why is it D? Explanation.
Charged particle should be zero, then it has nothing to do with charges, sign of the charges, no sir.
I'm asking for explanation. You're not giving explanation. If it is D for delta, why is it so? So basically, what you're saying in option D is that it will always be so. It doesn't matter which types of charges are there. Why is it so? Okay, I'll give you a hint. Apply Newton's third law. Two forces, if they act on different bodies, they don't cancel each other. You know that from Newton's third law. If they act on different bodies. But when we are talking about a system, then system includes those two bodies. Say for example, I hit myself. With my right hand, I hit my shoulder. So my right hand applied force on my shoulder. My shoulder applied force on my right hand. Okay? Right hand and shoulder both experience the force, but my whole body, did it move? Did it accelerate? No matter how hard you hit your own body, you can never accelerate your body. Because when body is your system, then the two forces are cancelling each other. You get the are you able to see the difference? Hand will say that shoulder applied me force. Shoulder will say that hand applied me force. But the body will say that the net force on it was zero. When body is a system, then the two forces are cancelling each other. When hand is a system, only one force is acting. When shoulder is considered, only one force is acting. Newton's third law works like this. If you take two charges, for example, both are positive. Charge 1 will say, charge 2 is pushing me. Charge 2 will say, charge 1 is pushing me. Right? That's what Newton's third law says. Forces are equal, opposite, they act on different things. So they don't cancel. One is not saying, I'm experiencing zero force. 2 is not saying, I'm experiencing zero force. 2 is saying, I am experiencing some force. Likewise, 1 is saying, I am experiencing some force. But if I have a plastic piece, in which these two charges are embedded, Does the plastic piece move? No. Plastic piece does not move. Aren't these two forces acting now? They are acting. One will still say that 2 is pushing me. 2 will still say that 1 is pushing me. But what will the plastic say? I will not move. I have nothing to do with their fight. As a system, I am experiencing zero force as a system. So whenever you consider a cluster of points as a system, then action and reaction forces do cancel each other. So when you learn Newton's third law, then you learn that the forces act on different things. But if you take the whole thing as a big system, then everybody is part of that big thing. And then they do cancel each other. So this plastic thing on which these are embedded, that will never accelerate. Inside your body, how many charges are there? How many electrons are there inside your body? How many protons are there? Aren't they quarreling or attracting each other? Protons quarreling with other protons, electrons attracted by protons. Do you really feel that? Does that accelerate you? No. Only ground accelerates you when you walk. It's the ground that accelerates you. So it doesn't matter whether you have got both plus, both minus, 1 minus, 1 plus. When you take the whole system, picture of the whole system, then these forces do cancel each other. So answer is option D. And if you have any clarification, then let me know. So what do you think?
So option C, because action and
So option C.
are equal in magnitude.
So option C, using Newton's third law.
Option C. Any questions? Let me know. So it comes from Newton's third law. Here you have to give a theoretical answer. If it is non-zero, you have to say yes. So all possible options you have to think about. Let me just
So one of
add
them would be new.
just a
Except
moment.
electromagnetic or A, C and D.
No, weak force is for particular nuclear reaction. Just a moment. First of all, let me make one change or one addition. On a proton in the same nucleus. A neutron cannot apply force on a proton in another nucleus, right? Same nucleus is what I'm going to add. In the same nucleus. Nuclear force is going to be there in the same nucleus. Yes, now you can try.
Option A and C.
A and C. Now they're in the same nucleus, so nuclear force is going to be there. Gravitational force may be meaningless, but it is non-zero. Electromagnetic, no. Neutron has no charge. Weak force is when nuclear reaction takes place, like beta minus emission or beta plus emission. We are not talking about nuclear reaction here. AC is right. Any questions? If you have, then let me know. More than one may be correct.
Sir, A and B. A and B.
A and B. Nuclear force is always greater than electromagnetic force.
Sir, between two protons there is no nuclear force.
Why? Aren't they nucleons?
Protons. Acha, okay.
A cannot be correct. What if one proton belongs to helium atom, other proton belongs to sodium atom? What will be the nuclear force between them? Zero. Nuclear force is meaningful if we are talking about the same nucleus.
Sir, answer B alone.
B alone. Electromagnetic and gravitational. Always electromagnetic will be more. K Q1 Q2 by R square and G M1 M2 by R square.
Sir, B alone. Only B.
B is certainly correct. Whether it's alone or not is a different thing. B is certainly correct. Now C. What's
C is
wrong
not
with
correct.
C? Why
So
not
because
correct? It's
nuclear.
maybe. Maybe.
If in the case if like helium and sodium, if two protons are different, then it can happen.
Correct.
But D won't be like that.
So because of maybe, C is correct, isn't it?
B and C.
Let's look into D also. Electromagnetic between two proton maybe. Here also it's maybe, so shouldn't it be correct?
But proton has no charge, so why should electromagnetic force come into the scene?
Can you repeat?
Protons has no charge, so why should electromagnetic force appear in this
Proton
thing?
has no charge.
Yes, sir. Oh,
What?
sorry, neutron has no charge. Oh,
So what about D?
no. Nuclear force is greater, but for same atom. It's also possible for the maybe case.
Maybe case is possible. If gravitational force can be more, if option C can be correct, which says gravitational force may be more, then electromagnetic force beats gravitational hands down. If C is correct, what's the problem with D?
C and D. Correct.
Sir, can we also say A may be correct if by chance both the protons tend to be in the same nucleus?
But there is a word maybe. Always.
There's no maybe.
Always is the language which is used in option A.
A had a maybe, then that would be the most strongest, no sir?
If A had maybe, in that case, what will happen? In that case, all correct. In that case, all correct. A, B, C, D. Yes, go ahead.
Right, I got it.
All right. What do you think?
For sure, but C I'm not sure with. D is absolutely wrong.
You're saying B is wrong, beta is wrong, or delta is wrong?
Delta. The Earth could not move around the Sun because gravitational force is responsible for that.
Correct. So D is certainly wrong.
And A, there would be no force of friction because no charges means no opposition, so no friction. That would be correct. And B, there would be no tension in the string. Ultimately, it is also a type of electromagnetic this thing, so that would also be correct.
And what about reaction force? Is it not electromagnetic?
Yes, sir. Reaction force is also electromagnetic. So ABC.
And D is because of gravitational force. And gravitational force has nothing to do with this. So it should be ABC. Now that's a different story altogether, that if there are no neutrons, then how will the world exist? How will the Earth exist? That's a different question. ABC. Any questions? Let me know. I had said something about it, so try this. Yes, go ahead.
So option A and B.
Yes, sir. A and B.
Big particles speed much lower than the speed of light. That is the scope of classical physics or Newtonian physics. So yes, cricket ball, dust particle are fine. Hydrogen atom, no. Nuclear reaction, no. AB. Any questions? Let me know.
So C and D both belongs to quantum physics.
Well, quantum numbers, Schrodinger's equation, what are those things? Cloud picture, orbitals,
Quantum.
Schrodinger's cat. Schrodinger's cat is, by the way, very famous paradox. You can read about it. Till date, no solution has been found to Schrodinger's cat problem. That's thanks to quantum physics. So what about this one?
So B, C and D.
So all of the options.
What's wrong with A?
So all of the options
All
are
options.
correct.
Act on different objects is certainly correct.
Sir, I had a doubt in A option. Sir, then all of them.
Doubt in option A. What is your doubt in option A?
Sir, I thought that normal and reaction and action are acts on the same object.
Action and reaction always act on different objects. That's
Okay,
Newton's
sir.
third law.
Okay, sir.
Equal magnitude, yes. Opposite direction, yes. And yes, they do cancel each other, provided you are considering the big system. But if you consider individual objects, no, they don't cancel. In fact, that's how often we accelerate ourselves. How do you walk, for example? Because you apply force on the ground. Ground applies force on you. So for individual objects, they don't cancel. But if you consider a big picture, big system, then they cancel each other. So in this case, because big system is to be considered, D will also be correct. Any questions? Let me know. This one I will discuss. One of the key things in this topic is the ability to draw what is called as the free body diagram, FBD in short. That means you decide your system and you just focus on your system. Sometimes system can be an individual body, sometimes a system can be a cluster of bodies. And then you just focus on that system. Show all the forces that matter to you on that system. Here, we have to treat B as our system. List all forces acting on B. This man is not touching B. So while this man could be the reason why B would accelerate, man could be the reason, that does not mean that man is applying force on B. Man is applying force on A. Man is not even touching B. How can he apply force on B except for gravitational force, which is of no use? So A applies force on B and they are in contact, so that will be electromagnetic force. And that force will act on the right side for B. We call it reaction force by A, N, right? So man applies force on A applies force on B. Man does not apply force on B. Then B is kept on the surface. So B will press the surface down. It is not gravitational force. It is the electromagnetic force. So B presses the surface down. Surface presses B up. That's the reaction force by the surface. That is electromagnetic. N dash. Both N and N dash are electromagnetic forces. Earth, that's the only fellow who is applying some meaningful gravitational force. And Earth will pull B by that force in downward direction. And that is mg. Now if we were moving, sliding, and we wanted to show frictional force also, then we would add frictional force in this manner. We always show frictional force acting where the two surfaces are in contact. That's where we show the frictional force. Where the two surfaces are in contact, that are rubbing or that are in contact with each other. So if we want to show frictional force, it would be shown like this. Normal reaction you always show from the surface. N dash should be shown from the surface. N should be shown from the surface. Gravitational force is not shown from the surface. Gravitational force is shown from the center of mass or center of gravity, if you like, of the body. Actually, Earth applies force on individual particles of any body. This particle in B is pulled by Earth, this particle is pulled by Earth, this particle is pulled by Earth. So various particles inside B are pulled by Earth. So it becomes too complicated. So we just choose one point inside B, which is called the center of mass or for our purpose right now, center of gravity. And from where we show mg acting. So often when we draw FBD, we also take that body apart. So a fresh drawing can also be done, B shown like that, and then all forces that I have shown like this, N, then mg from center of mass, N dash from this surface like that, and if friction is to be shown, that will be shown from here, like this. That is friction. Okay, so that's very important in this topic, free body diagram. Students otherwise tend to mix things because you sometimes you think that that man is responsible for moving B. That's correct. That man could be responsible for moving B. But being responsible is English, applying force is physics. Man is not applying force on B, that's what you have to understand. So you don't show that force. But if you are to consider A, then yes, you will say that A is pushed by that man. So that force applied by the man will be shown on A. But man is responsible for moving A also, moving B also. But man is applying force only on A. Any questions? Let me know. Yes, go ahead.
So the frictional force is applying a force in the opposite direction. So where do we have the reaction for this force?
Table. This table. If you are to draw the FBD for this table, then you will show the frictional force on the right side acting on the table. That's a pair for this. In fact, that's important to understand that, because often it is not shown. Like I have not shown because I was interested in B. Often it is not shown because you're not often interested in the table. But suppose, let me make it like this. In place of table, like this, 2 blocks. Now we will be interested in both of them. So when you're looking at the top block, then you will say that top block presses the bottom block applies a normal reaction like this. Then earth pulls the top block. That's the story of the top block. But when you look at the bottom block, I'm showing it here, earth will also pull it down. Let's say capital Mg. Surface, this will apply some normal reaction. That is not n, that's n dash. But this top block will push it down. And it will push it down by the same force, n. That's Newton's third law. Like this. That is n. So here also, the n dash that you are looking here, that table is experiencing n dash. If table is your system, then n dash is pushing it down, and it is electromagnetic force. So everybody has got a partner. It's a question of whether we are interested in showing the partner or not. Just for the sake, everybody gets the same answer. Take your mass as 50 kg. Take your mass as 50 kg. And if you need the mass of the Earth at all, you can find it out. And tell the direction also. Calculate the force and tell me the direction also. Take your mass as 50 kg. No, not now, not now. And this is your assignment question. We stop now.